So now we're on to part 2, and the first part is 5.5. At this point, we've learned all about like what a domain and range is in terms of like domain is your independent variables, and then your range are your dependent variables. But what about describing the domain and range? So just to kind of refresh, a domain are all the elements that are independent variables. They're often represented as x variables, and they're found on the horizontal axis. And what I mean by found on the horizontal axis is like if you have a graph here, your domain is on the horizontal axis and your range is on the y-axis. Now, something you gotta really understand is mathematicians are lazy. They don't like describing things in words. They don't like using long sentences. They want to be very logical. They want to note things very quick. So what we do is we are going to learn how to use logical expressions and symbols to describe all different types of things. Okay, so we've already kind of seen set notation and realize in our past videos we have mentioned the domain of certain things. So such as, where's an example here? We wrote our domain, we literally just wrote the domain and range out, okay? But we need to even do it more mathematically, okay? And that's where this kind of come in. We need to know some things about set notation. So set notation is a formal mathematical way to express the domain and range. So understand we need to use these type of brackets when determining something that's a part of a set. So we've kind of talked about it in a previous videos. Means an element of, what am I talking about here? This is the little e, okay? So you can see that here. When you write a little e, that means is an element of, and this little line here that you can find here is known as such that. Okay, so let's read this out. So something you're gonna have to get used to is the domain is this set, and this set is x such that x is greater than or equal to 3, comma, where x is any real number, and I'll describe these symbols down below. But let's write that out. So this is known as the domain, which is represented by this d, okay, is x such that, and that's where you get this from, x such that x is greater than or equal to 3, where x is any real number when it is a number. So as you can see, this thing right here literally says this entire sentence. So it's going to take a bit of practice getting used to that. But just understand, we're talking about our domain. Our domain includes what's listed here. What's listed here is our domain is x, such that x is greater than or equal to 3. So any number that's greater than or equal to 3 is a part of your domain. And when x is a number, x is an element of the real numbers. The real numbers include all rational and irrational numbers. So this is known as set notation, also known as set builder notation. Okay. So this is set builder notation here. Set interval notation is a little, some people find it easier, some people might actually struggle with it a little bit more. It depends. You have to know how to do both. So this uses different brackets to indicate the interval. An interval is just like things that are included. So some things to note is you have these square brackets here. Okay, square brackets means the number is included in the interval. Okay, so here we see square brackets used. So that means 3 is included in your interval. Rounded brackets means the number is not included in their interval, such as here. So I can read this describing words. This is the domain has the smallest number, or let's start over here. It's easier described as the smallest number in our domain is 3, and 3 is included. Our largest number goes to infinity. So believe it or not, here explains the exact same domain as this. X would be larger than or greater than 3, or sorry, larger than or equal to 3. So we go all the way to positive infinity. Now recognize, we use a rounded bracket anytime we talk about infinity because you can't equal infinity. Because you cannot equal infinity. Okay, so here's some things that you learned in grade 9. Okay, so recognize when you use these inequality symbols, your larger number is always stated where the larger side of the inequality is. Another way to remember it is the alligator, okay, always wants to eat the larger meal. Okay, so here X is larger than 3. Now you see that little line there. When you put a line, that means to include the number as well. So this says X is greater than or equal to 3. The number on the side where it comes to a point, that's the smaller number. You can either think of it's visually smaller or the alligator wants to eat the bigger thing. You also have a not equal sign that you can include. And here are those letters that you're going to want to kind of remember. Something to note. You're pretty much always going to state real numbers because real numbers includes every number you can think of. And for right now, at least pretty much 99% of the graphs and the things that you're going to have to explain are going to include the real numbers. There might be the very odd question. I would say that's a tougher question. That might just include integers, which is Z. So integers are -1, -2, -3, 0, 1, 2, 3, so on and so forth. Okay? But again, you pretty much are always going to state that your domain or range includes all the real numbers. Okay, so let's see some examples here. So essentially, we have to understand to include or not to include. So this is something you learn in grade 9 again. Sometimes your domain and range will be smaller or greater than a number, but not including it. In grade 9, you learn how to work with the inequality symbols. So remember, this is greater than or equal to, greater than or equal to. On a graph, a number line is included if you have a shaded in circle. So see how we have a shaded in circle here? That means to include the number 2. So if we were to describe this thing using set builder notation, we would have to say, well, this set here, let's call these numbers X. So let's say this represents the X line here. So this is our X line. What numbers do we include? Well, X is such that X, well, here we see it shaded in on 2. So X not only has to be greater than 2, see how we're getting bigger, but we can also include 2. So I'm going to put a line there. And what type of numbers can it be? Well, it looks like numbers can be in between 2 and 3, 3 and 4. It can be a decimal number. It can be an irrational number. So X can include any real number. And there I've stated essentially my interval here. I could also use my set interval notation. Here, my smallest number is always listed first, which is 2. I need to include 2, so I'm going to use a square bracket. And I'm going to press comma, or input comma, and now this is going to be my largest number. Well, my largest number I'm never going to get to because it's going all the way to positive infinity. So I'm going to put positive infinity. I'm going to use a rounded bracket because remember, rounded means to not include. We're never going to be able to equal 8. So here I have describe this line. Let's look at this one here. So if you have an open circle, remember, that means that number is not included. So here, this is do not include 4. So how would I write that? Well, here, let's call this all numbers. Let's call it J. Okay, so these are the numbers J. So here, what kind of numbers can J be? Well, J, let's start at 4 here. J can be greater than 4, right? Because we're going all the way past 4, so greater than 4. Oh, sorry. So J is greater than 4, right? 4 is smaller than J. That's what this says. So that means J is greater than 4. Remember, your alligator always wants to eat the bigger thing. And we're not going to put a line underneath here because 4 is not included. But I do have to mention that J can be any type of number we're talking about, any real number. See how any number between 4 and 5 can be included? So any decimal, fraction, irrational, rational number can be included. Okay, so this is known as your set builder notation. Okay, and then you need your interval notation. Well, here, what's my smallest number? We always list the smallest number first. The smallest number is 4. And I'm not going to include 4, so I'm going to use a rounded bracket, right? Do not include 4. And then what's my largest number? Well, my largest number is going to go all the way to positive infinity. And then I'm going to do another rounded bracket. So you can see here that these are stating the same things, just using set builder notation is a little different than using interval notation. Okay, so let's do a few more difficult ones here. So let's look at this one. So I'll kind of zoom in on this side. So example 3, write the domain and range for the following 2 graphs. So remember, your domain is your horizontal line and your vertical line is your range. Okay, so let's talk about domain first. So what type of numbers can my horizontal domain numbers be? Okay, so in this case, in words, my smallest number is -5. So we can see here on my domain, my smallest number is -5. And my largest number of my domain is 1. So in words, it would be greater than -5 and less than or equal to +1. Right? That's in words. So our domain can either be greater than -5, but not including it, and it can be less than or equal to 1 because we have a shaded in circle. Let's use a number line. On a number line, we would state, well, here we can go all the way to -5 and all the way to 1 here. This would be an open circle, and we can be any number in between -5 and 1. And 1 we can include. So that's why I used a shaded circle, and we can be anywhere in between there up to -5, but not including -5. Okay, and here's the real mathy part. Let's say this in set builder notation. So my domain, I'm going to write D. And now I'm going to explain what's in the domain set. Well, my domain are my x values such that, okay, so I'm going to talk about my x values, and these are now what my x values can be. Well, my x value has to be greater than -5, right? Because your alligator wants to eat the bigger thing, okay? And recognize we're not going to put a line underneath because it doesn't include -5. And x is also smaller than 1 or equal to it. So this is also smaller than or equal to 1. What type of numbers can it be? Well, we can see that our line exists continuously. So my x values, when they are a number, they can be any type of number. Okay, so there is my set builder notation. Let's go on to interval notation here. So interval notation, usually you want to represent, hey, I'm going to be talking about my domain. Now, what's my smallest number of my domain? Well, it's -5. Do I include -5? No, I don't, because it is a circled. Okay. Now, I'm going to put comma on what's my largest number? Well, my largest number is 1. And I'm going to include my number 1 because it's shaded in. And now I've listed my domain in all 4 ways that you need to know how to do. Let's go to my range here. So range, now we're talking about the numbers on your vertical axis. Okay, so what type of numbers can my plots be in terms of my vertical axis? Well, here, what's my greatest number? Well, my greatest number is 1, but I do not equal 1, okay? If we look down here, my smallest number for my range is -3, and it looks like I can equal -3. So here, I have to be less than 1 and greater than, let's make that a little bit more legible there, and greater than or equal to -3. So we can see that here. Is this statement true? We can be less than 1. That is true. 1 is here and we can be less than it. We never state that we can be equal to it. All we have to be is less than it, or we have to be greater than -3, and we can be equal to it. So that includes these portions, which is true. Okay, let's show this on a number line. So on a number line, my range would look like this. My largest number is 1, and my smallest number is -3. I can include -3, and I do not include 1, and I can exist anywhere in between there. Okay, so we can see I've now shown my range using a number line. I have to be greater than or equal to -3 up to +1. I have to be less than 1. Let's use set builder notation. So here we're talking about the range. So I'm going to state that this is R. And now I'm going to open up a set. And what is my R values? Well, usually you just assume it's Y, unless it is not. Sometimes it's height. So you'd put H, whatever this vertical axis has for its variables. But if they don't give you a variable, you can assume it's Y and X on the domain. So here we're talking about range. So what can our range be? Well, my Y value has to be greater than, right? So our alligator eats the bigger thing. What does Y have to be greater than? Y has to be greater than -3. And remember, it can also equal -3 since it's circled in. So this is equal to. Y can be less than, and Y has to be less than 1. So it has to fall in between these two numbers. We cannot equal 1, so I'm not going to put a line there. And now Y can be any real number when it is a number. And that's true because, as you can see here, our line exists between these two numbers. Let's use set builder notation. So here we're talking about range. Okay, what's my smallest number? My smallest number is -3, and I include it. So remember, you always state your smaller number first, and this is including -3. Okay, and then what's my largest number? Well, it's 1, and in my range, I do not include 1 because it's an open circle. So this will be 1, and a rounded bracket. Okay, so there is stating this graph in 4 different ways. Let's do one more. Let's do over here and go from there. Now you can kind of see that this just goes off the graph. This just means this continues forever. At least you can assume that. Okay, so let's look at our domain. So our domain in words, remember, what is your domain? Your domain is everything on your horizontal axis. So my largest number I can see here is -2. I'm not going to include -2. So here, my domain has to be less than -2. And that's literally it. You don't have to state that it's going to go to negative infinity. As long as you say that your domain has to be less than -2, you can assume any number smaller than -2 is a part of your domain. So you're done there. Now, let's explain our range. Let's kind of do it at the same time. My range is on my vertical axis. So what's my largest number of my range? Well, the largest number of my range is 1. I don't include that number, but I can be any number smaller than 1, as you can see here. And this continues on forever and ever and ever and ever. So that means as long as my range is less than 1, and I'm not going to include 1, right? So now any number, if I extended this graph and went all the way down to -10, I could find my line at the range of -10, somewhere over here. Let's use some line graphs here. So here, all I need to represent is -2. Okay, and remember, I don't include -2, and I'm going to go all the way to -infinity. So there I've represented my domain using a line graph. Let's represent our domain, or our range, using a line graph. So remember, our largest number is +1, which is right here. And I'm not going to include this largest number, and you can be any number smaller than it. So there is my range. Now we're going to do set builder notation. So this is the new stuff. So my set builder notation, my domain, I'm going to represent, okay, I'm talking about my domain and I'm going to open up my set. Okay, since these aren't labeled, I can assume that my domain is X. So X such that, and what can X be? Well, we just said X can be less than -2. We're not going to equal it. So X will be less than -2. Now when X does end up being a number, what type of number? Well, X can be any real number, because as you can see, we have continuous data here. So X includes any real number. And there is your domain represented. Let's talk about our range. So the same thing, I'm talking about my range, and my range is this set. What is a part of my range? Well, this isn't labeled, so I'm going to assume my range is just Y. Y is such that Y is less than, and I'm not going to use the equal sign. I'm not going to put a line under because we don't include our largest number, which is 1, where Y is any real number. So remember, we have 1 here, we don't include it, and we keep going down and down and down. So number 1 is the biggest number of our range. So Y has to be less than +1. Now let's represent this using our interval notation. So interval notation, remember, we're going to talk about our domain. And remember, interval notation, the first number you state is always the smallest number you're talking about. So what's the smallest number we're talking about in our domain? Well, remember, this goes on forever. So our number, once we're smaller than -2, will go all the way to -infinity. So we could just keep going to the left of -2. So my smallest number is actually -infinity. And remember, we're going to use a rounded bracket because we never include -infinity. Okay? What's our largest number? Our largest number is -2 in our domain. Can we equal -2? No, we can't, because it's a open circle. So I'm going to use a rounded bracket to not include -2. Let's try out our range. So our range, again, we are going to list our smallest number first. So what's my smallest number? My smallest number, as you can see here, we start at 1 and we keep going down. We keep going down. So this will go, again, to -infinity as well. And we're not going to include -infinity, so we're going to use a rounded bracket. What is your largest number in your range? Well, my largest number is 1, okay? And we don't include it, so I'm going to use 1 here, and I'm going to round the bracket, okay? So there's me stating the domain and range 4 different ways for this graph and 4 different ways for this graph. This takes a lot of practice to get good. So make sure you open up your textbook, go to your AFL and practice, okay? And recognize and remember, whenever you're doing set interval notation, okay, it's always smallest number, and this is your largest number, okay? Remember, you might have square brackets to include that number and rounded to not include, okay? So let's do one more example. And this example is a little different because here you notice that this is discrete data. So this is just something I really want to mention. When you list the domain and range for a following graph that's discrete, you can't really use number lines because it's just simply points on a line. Okay, you have specific values that stuff equals, and you don't have continuous data. So your x value won't be every real number. Your y value won't be every real number. So when you're listing the domain and range of discrete data, you just list the data. So here, let's talk about our domain. Okay. And what is our domain? Well, you can see that this is telling us this is x. So you might not be able to see that, but this says x. So my domain, which is always my horizontal axis, is now labeled as x. X is, and what does x include? Well, here you can see x includes, this is 1, 2, 3. So x includes 3, 2, 1, 0, and then -4. So this would simply be 3, 2, 1, 0, and -4. And recognize we don't have any values in between there, so we can't say x can be any real number. We just simply list the data. Now let's talk about the range. Remember, the range is found on your vertical axis. Can't quite see that, but this says y here. So this has labeled your range as y. Now what can y be? Well, here, y can be wherever your discrete data is found. So this is -1, this is 0, this is 1. So far we have -1, 0, and 1. We skip 2. There's no point found on 2. There's no point found on 3, but there is a point found on 4. So 4. Here we are now on 5. We're on 6 as well. And finally, we are on 7. So now I've listed my discrete data. This doesn't happen a ton, but it is worth mentioning. This is the thing that you really got to get used to, as this is found in Math 30-1 and in 30-2. Okay? So let's maybe try out a few more examples just to get the good hang of this. So something to note, we kind of already talked about this, are when graphs go to positive or negative infinity. So you can assume a graph continues on forever if the end of the line has an arrow. So if it has arrows, you can assume it just keeps going on and on and on. Or the graph goes all the way off the edge of the graph. So this also just goes on forever. Okay, so you can assume that this breaks through and it just keeps going and going and going. It doesn't actually stop at that point. Okay, so both graphs go on forever. Okay, so let's look at example 5, and then you can go try a few practice problems out on your own. So example 5 says, determine the domain and range of the following functions. Okay, I'm gonna explain these both using set builder notation. Set builder notation, and I'm also going to use interval notation. Okay, so here, what's my domain? Well, if you look at this, this goes on forever and ever and ever. And this is actually going to keep going on to the right forever. So we're going to go to positive infinity using our domain. Remember, the domain is the horizontal axis, and the range is your vertical axis. Okay, as we can see here, our domain, x can be any number because it's going to keep going to the left and the right. So here, this is actually pretty simple to state the domain. So the domain is my x variables, and x is just going to be any number. There's absolutely no restrictions on x. Okay, if I wanted to state that using set builder, it looks a little funny, but realistically, the smallest number in my domain for my x values is negative infinity. This is just going to keep going to the left all the way to negative infinity. And then the biggest number is positive infinity. And remember, we use rounded brackets because we don't include these things. Okay. Now my range is going to look a little different. So my range, I'm going to say, is my y values. Okay. Now what can my range be? Well, my y values are such that y is greater than negative 3. So this is the smallest y value, and that's y equals negative 3. So here, y is going to be greater than, and it's actually going to be equal to negative 3 as well. So because we can see it actually hits negative 3. And now it's going to continue upwards forever and ever and ever. So as long as y is greater than or equal to negative 3, and when y is a number, what type of number is y? Well, this is continuous data, so y is going to be any real number. And there I've stated my range. Let's use it using interval notation. So my interval notation, what's the smallest number that's always listed first? Well, it's negative 3, and I'm going to include negative 3. So I'm going to use square brackets, and this is negative 3. And what's my biggest range value? Well, my biggest range value goes all the way up because this is going to continue up because of the arrowheads. So it'll be positive infinity, and I'm not going to include it because you can never equal infinity. And there is my domain and range represented in two different ways. Okay. Let's do B, and then it's time for you to try some examples on your own. Okay. So here, this one looks a little funny. I'm going to do the same thing. I'm going to do set builder, and I'm also going to do interval. Okay, so let's look at the domain first. You always usually start with domain. This time, I'm going to change it up a little bit. I'm going to say my domain values are t, and my range values are h. Okay, because it's not always going to be x, and it's not always going to be y. So here, my domain values are t variables. So my domain is t variables. And what can t be? Well, here, if you look, the smallest number t can be is negative 5. So at this point, my smallest domain number is negative 5. And as you can see, it's a closed circle. So that means I'm going to include it. So t is going to be greater than or equal to negative 5. This is going to go on forever in the domain way to positive infinity because it goes off the graph. So you can assume it keeps continuing on. And t is going to be any type of real number because it's a continuous data. Okay, let's state this using interval notation. So my domain, my smallest number listed first, and my smallest number is negative 5. And it is included. So square bracket, negative 5, all the way to positive infinity, and you're going to do a round bracket because you're not going to include it. So it's going to just continue on and on and on to the right forever and ever and ever. Now let's talk about the range. So the range, we have now stated that the range, which is our vertical axis, is h coordinates. So this will be h. Now what can h be? Well, my smallest number for my range is negative 2. This is my smallest range value is negative 2. And you can see it's circled, so it includes negative 2, and then it goes up forever. You can see this increases upwards. So h can be greater than or equal to -2, right? So we can include, so a number, we're going to put the line, and h is greater than because we keep increasing on the vertical axis. And since it's a continuous data, we're going to include every real number. So h is an element of every real number. Let's finish this off with some interval notation. So remember, always list your smallest number first, largest number second. So what is my smallest number? Well, again, we just said my smallest number of my range is -2. Do I use a rounded bracket or a square bracket? I use a square bracket because it includes, it's shaded in. And then we go to positive infinity because we can assume that this graph just keeps increasing upwards because it's just going to continue on up. So we do not include infinity because you can never equal it. And there I have stated the domain and range. So what I find with students is that when someone's explaining this to them, it makes perfect sense. But then when they go to it by themselves, it's a little confusing. So make sure you go practice, try some textbook questions, do the AFL for, this is a long 5.5, and please come in and ask questions, okay? We can really work through this stuff together and figure it out. So have a good day.